This is topic 13-2, powers of monomials. Our objective for today is I can simplify expressions involving powers of monomials. So our essential question is going to be, how can I simplify expressions involving powers of monomials? So by the end of this topic, you should be able to answer that question. Our bellwork problem is another review problem dealing with linear equations. Which graph best represents the line that has a slope of -5, 6 and contains the point 4, -3? So let's start off with, we know the slope is negative, so that means our line should be decreasing. From left to right, it should be going down, so F is a possibility. G, however, is increasing, so it is not a possibility. H, as I go left to right, is going up, increasing, not a possibility. J is a possibility, it is decreasing. Next, let's look to see which one of these two lines, or both, go through the point 4, -3. So I'll go where x is 4, that's along the x-axis to my right, down 3, 1, 2, 3, and F is not going through that point, but let's check J. We're going to the right 4, 1, 2, 3, 4, down 3, 1, 2, 3, and sure enough, J goes through the point, 4, -3 is on the line, and so our correct answer is J. These are the answers to assignment 13-1. You may pause the video in order to check your answers. Here are the answers worked out. Again, if you need to see how the answers were gotten, please pause the video at this time in order to check your answers. So our topic for today, we're talking about monomials that have powers with them. So when you are finding the power of a monomial, it's like using a big stamp. Notice in our equation today, or in our expression today, the exponent is outside parentheses. And we're going to use the exponent like a stamp again. So everything inside the parentheses is going to be stamped out 4 times. So here's 1, 2, 3, 4. Now, once we have the stamp, then we can use the same rules for multiplication in order to figure out what our answer is. That means we're going to do like we did in our previous lesson. We'll take our numbers and write them first. 1, 2, 3, 4 threes, cross them out. And then we have x times x times x times x. And now we can multiply our numbers, 3 times 3 times 3 times 3, and that will give us 81. And then we'll have x to the 4th power. Because our multiplication says if they have the same base, then we can add the exponents. Or, because our 3's have the same base, this could also be 3 raised to the 4th power times x to the 4th power. So our exponent tells you how many times to stamp out that monomial, and then you follow the rules of multiplication of the monomials. So let's do a couple examples. First, we're going to expand 2x to the 4th raised to the 3rd power. So again, we have an exponent on the outside that tells us how many times to stamp out the parenthesis. So we're going to do 2x to the 4th power. We'll do it 3 times, 2x to the 4th and 2x to the 4th. This will give us then, if I do my numbers first, 2 times 2 times 2. And then x to the 4th times x to the 4th times x to the 4th. We're going to go ahead and multiply out our numbers, even though they have the same base. I know this is 2 to the 3rd power, but I'm also going to multiply it out. And 2 times 2 times 2 is 8. And then for our x's, we're going to add up 4 plus 4 plus 4. And that'll give us 8x to the 12th power. 8 times x raised to the 12th power. Only the x is being raised to the 12th power. So now we're going to simplify some. We're going to start real simple and then get a little bit more complicated. Again, starting off with the 4 is the exponent on the outside that tells us how many times to stamp out the parenthesis. So we're going to stamp it out 4 times. So x squared, we're stamped out 4 times. And now let's use what we know about multiplying monomials. They all have the same base of x. That means we can add our exponents. 2 plus 2 is 4, plus another 2 is 6, plus another 2 is 8. So this is x raised to the 8th power. Number 2, we're going to use our 2 that's on the outside to stamp out what is on the inside parentheses. So we have 2a to the 7th stamped out twice. Again, using our what we know about multiplying monomials, this will be 2 times 2, and then a to the 7th times a to the 7th. So 2 times 2, again, go ahead and multiply that out to be 4. And a to the 7th times a to the 7th will be a to the 14th. Number 3, our exponent on the outside is 3, so we are going to stamp out what the parenthesis 3 times. 4a to the 4th, 4a to the 4th, 4a to the 4th. Equals, we have our 4 times 4 times 4, and then a to the 4th times a to the 4th times a to the 4th. 4 times 4 is 16, times 4 is going to be 64. And then our a, 4 plus 4 is 8, plus another 4 is 12. So a big difference from yesterday and today is that we are taking our numbers and going ahead and multiplying those out. Problem number 4, we have c to the 5th times c squared raised to the 3rd power. So notice in this one that the exponent outside the parenthesis, that's the one we are going to stamp out. It's just the c squared, and we're going to stamp that out 3 times. So the c to the 5th power just stays as c to the 5th. And now let's stamp out our c squared. So that's 1, c squared is 2, and c squared, that's 3. Now we can use what we know about multiplying monomials. We have all the same bases, c. That means we can add our exponents. 5 plus 2 plus 2 plus 2. And that will give us a total of c raised to the 11th power. Number 5, again, I see I have a 4t squared that is not in parentheses, so I'm just going to rewrite it, 4t squared, take care of that. Now I do have the negative 2t cubed, but that's raised to the 3rd power. So this 3 on the outside tells me how many times to stamp that parenthesis. So negative 2t cubed, that's 1 time. Negative 2t cubed, that's 2 times. Negative 2t cubed, that's 3 times. Let's put all our numbers in front. We have 4. It's the first 4 times the negative 2 times the negative 2 times the negative 2. Then we have t squared times t cubed times t cubed times t cubed. Now we will multiply out our numbers front. And since I have a lot of negative numbers and positive numbers, I'm going to go ahead and bring my calculator out in order to check my answers. So with my calculator, I'm going to type in the numbers that are given up front. It'd be 4 times a negative 2 times a negative 2 times a negative 2. That will be a negative 32. And then let's add up these exponents for the t's because they have the same base. So this will be 2 plus 3, that's 5, plus 3 is 8, plus another 3 is 11. So I have a total of t raised to the 11th power. Number 6, I now have 2 sets of parentheses, so it's important that I stamp them both out. So start with the first one. These parentheses are raised to the 2nd power, so that means I need to stamp that out 2 times. So a to the 4th and a to the 4th. There's my 2 times. Next, we have our second set of parentheses. Its exponent is to the third power. So everything inside of there, I'm going to stamp out 3 times. So a squared, that's 1, a squared, that's 2, a squared, that is 3. Now we can use our properties of multiplying monomials. They all have the same base. This means I can add the exponent. So the base stays the same of a. Let's add our exponents. This be 4 plus 4 plus 2 plus 2 plus 2. You can use your calculator or you can do this in your head and you will get that this simplifies a to the 14th power. I know some of you are going to want to take a little shortcut, but I ask that you continue to stamp it out and use what we know about multiplying monomials. Number 7, our first set of parentheses, notice it is not raised to any power, so we're just going to rewrite it, c squared. Our second set of parentheses, however, is raised to the power of 2. And so we're going to stamp that one out 2 times. 3c to the 5th, that's 1 time, and 3c to the 5th, that's 2 times. Now we can rewrite with our numbers 3 times 3, and then also our variables, c squared times c to the 5th times c to the 5th. Our final answer, 3 times 3 is 9, and then we add up all our c's, we get a total of 12. So our answer is 9 times c raised to the 12th power. Number 8, again we have our first parenthesis. It is raised to an exponent. That exponent is a 2, so we're going to stamp out that first parenthesis 2 times. Our second parenthesis, it is raised to an exponent of a 2, so we're going to stamp out that parenthesis 2 times. So 5m cubed, that's 1 time, 5m cubed, that's 2 times. Now, let's rewrite using our numbers first. So we have 6 times 6, and then 5 times 5. We have m's, so m from the first one, m from the second one, m cubed, and m cubed. Taking care of all our m's, and now n's, we have an n and an n. Recall that if it doesn't have an exponent, there's an understood 1. So now we'll use our calculator to multiply those big old numbers up front. That is 6 times 5 times 6. Let's start that again. 6 times 6 times 5 times 5. Press enter. We have 900. Now we'll count up all our m's. This is 1 plus 1, that's 2, plus 3 is 5, plus another 3 is 8. So there's a total of 8 m's. And then n raised to the second power because we have 2 n's. So our final answer is 900 times m raised to the 8th power times n raised to the second power. Our last one, we want to find the area of a square that has a side length of 3x cubed. So let's think, it is a square and the side length is 3x cubed. If it is a if it is a square, that means all sides are 3x cubed. To find area, we're going to multiply the length times the width. 3x cubed times 3x cubed. I need to write 3x cubed. I'm writing 3x squared. So now, using what we know about monomials, we'll put our numbers first, and then x cubed times x cubed. We'll end with 9x to the 6th power. Some of you may have recognized or thought, okay, the area of a square, it's the side square, so I could also write this as 3x cubed squared. Notice that will give us our what's inside the parentheses stamped out twice. So to answer our essential question from the beginning, which was how can I simplify expressions involving powers of monomials, what we ended up doing was we took the power of the monomial and stamped out the monomial. So let's write that. You take the power of the monomial and stamp out the monomial. I'm just going to keep it like that. Then we used our properties of multiplying monomials. To simplify the expression. Now, if you want to, you can give more details. I'm going to give an example. So if I have 2x and then it's cubed, it's raised to the power on the outside. We're going to stamp it out 3 times. And then using what we know, this is 2 times 2 times 2, x times x times x, and that'll give us 8x cubed. So this concludes the topic 13-2.